guy. And today, just like at the end of class on last Wednesday, this section, which is section 1.4, is all about solving quadratic equations. Okay, so in the lead up to test one, we were basically learning all of these skills that at the time, they probably didn't seem like they were related to each other. We did some fraction stuff, some order of operations stuff, and then we started solving linear equations. And it turns out that you sort of need to be able to work with algebraic expressions in order to solve linear equations. Well, in the lead up to solving quadratic equations, we looked at polynomial expressions, knowing how to identify what type of polynomial expression we have, adding, subtracting, and multiplying polynomial expressions. We looked at factoring polynomial expressions. And then we sort of took a weird, seemed like a weird detour, right? Where we started working with simplifying radical expressions. And really, these three things are probably the most important parts that will contribute to us understanding how to go about solving quadratic equations, because there are going to be three main strategies for solving quadratics. So at the end of last time, we saw the first method for solving a quadratic equation, which was solve the quadratic equation using the square root property. So I wanted to do a few of those kinds of problems to try to just refresh our brains on how these quadratics work. Okay, so let me grab a problem as I'm sure that you guys are writing this stuff down. So the example in the homework or the instructions will say solve using the square root property. And just as a reminder, the square root property is basically saying that if you have some expression that's x squared that is raised to the second power, and that's equal to some number, k. This is your typical form of that kind of quadratic. Remember, a quadratic equation will have the second power because it is some expression that is squared. And then the way I try to link that into your brain linguistically is that in Spanish, squared means cuadrado. Well, if you have this situation, we need to cancel out the second power, which is why we discussed that the second power and the square root are opposite operations. So what we can do, just like when we solved, sort of like when we solved linear equations, we can do something to both sides of the equation. And that something here is taking the square root of both sides of the equation. When you do that, the square root symbol and the second power, because they have the same index, remember that the index on this radical is a 2. Because they have the same index, they will cancel out, leaving you just with x, which is what we're trying to find. And that's going to be equal to, and here you have to be careful, it'll be equal to plus or minus. Remember, you have two solutions for quadratics. The square root of whatever the number k is. Now, this k could be a number. It could be an expression that we have to simplify. But in any case, this is the general set of steps to go about implementing the square root property. So for a concrete example, if we had the equation x squared is equal to 17. Let's go ahead and maybe zoom in. Okay. So if you had this example, x squared is equal to 17, it's basically in the exact same form as this stuff over here. What I can do is just rewrite the example given, the problem that's given. And then I can say, okay, to cancel out this square, I need to take the square root of both sides. So I might write myself a little note here that says take the square root of both sides. Okay, now that will allow me to cancel out the root and this exponent since they're inverse operations. And that will leave us just with x is equal to plus or minus the square root of 17. At that point, you might just ask yourself, okay, can the square root of 17 simplify? Well, 17 is a prime number, so its only factors are 1 in itself. In this particular case, since we cannot factorize 17, that means we cannot further simplify this radical expression. So this number, whatever it is, and it is a number, even though it has an operation on it, it's something close to 4.12. But in any case, we don't want the approximate answer. We want the exact solution. So our solution set, since we can't simplify any further, is just going to be the set of these values. One of them is negative square root of 17, and the other one is the positive square root of 17. And so those are the two solutions that are possible for this quadratic equation. Does anybody have any questions about that one? Okay. Let's take a look at maybe a set of 3 problems here. I really want you guys to, really dig into the problems because you're the ones that are going to be working these problems on the test. So you have to be able to go through the mechanical process and the psychic process of looking at the numbers and the symbols and then sort of figuring out what they're asking you to do. Okay. So let's see. Let's do this. Practice. Okay, and I can hear the train rolling through, so I'm going to just mute myself while I write these problems down, okay? Okay, I think that train rolled through. All right, I'm gonna go ahead and open up some breakout rooms, probably just two big ones, so that you guys have opportunities to talk with each other. And I will be in just a second to go ahead and talk you through or talk you off the ledge for these problems. Okay. Okay, the breakout room invitations have gone out. So please accept the invitation. At least once you've written the problems down. Okay, well, this train is about to keep on rolling. We're about to leave the station. Let's go ahead and jump into number 2. And with great problems comes great necessity for more space. So let's start on a new page. X minus 4 squared minus 12 is equal to 0. Okay, we want to solve this using the square root property. And maybe the first mistake that some students make is they want to like just jump into this problem and immediately they start. So let me write this note. Don't do this. They immediately start and just take the square root of this side and take the square root of that side. And then they say that this is x minus 4. Maybe they neglect this thing over here and they just say that that's minus 12 or something like that. And then the square root of 0 is 0. This would be bad. And as I discussed with some of you guys in the breakout rooms, if we look at the square root property, you first need to have the square root expression, the squared expression with the power of 2 isolated. So all the other numbers are moved to the other side of the equal sign. So we need to make sure that before we go ahead and use the square root operation to cancel out the square, that we need this expression that has the square by itself. So right now, if we look at the original problem, so maybe I should say, this would be bad. Don't do this. I think it's important to highlight the mistakes, but please don't do that. What you want to do is carefully walk through this. So let's set this up again. And if this guy, the negative 12, currently it's negative, right? We need to be really playful with the signs here. Currently it's negative, but it's taking up the role of the k. And we need to move the k to the other side of the equation. Well, the principle of addition is still in play. That's never going to go away. So we can always just add 12 to both sides so that we can cancel out the 12s here. Okay. And now we have something that looks like x minus 4 squared. And that's by itself. We've isolated the squared expression, and that's equal to 0 plus 12 is positive 12. So now we have k on the other side. That's the proper setup. Now, once you've isolated the squared expression, I'm just going to put exp for expression. Then we can go ahead and say, let's take the square root of both sides. Take the square root of both sides. That is us using the square root property now, because we're trying to cancel out the square root and the power of 2, which leaves us with x minus 4, and that's equal to plus or minus the square root of 12, but we have to simplify. And we can say that 12 is equal to, and this is some scratch work, it's equal to 3 times 4, 3 is prime, this is 2 times 2, so 12 is equal to 2 squared times 3, and if we take the square root of 2 squared times 3, you get 2 root 3. So we should have plus or minus 2 root 3 there. Okay, I'm going to sort of shift this over here so we have a little bit more space and it's not running into our scratch work. So x minus 4 is equal to, and then you might remember vaguely from last week, I said, leave yourself a little bit of space here, and it's going to be important to do that. And then we'll put plus or minus 2 root 3. Now, the reason why I like to put this little gap is because we need to isolate the x. So to do that, we will add 4 to both sides. And since this is not a radical expression, I can't combine those terms. They're not like terms. One is a whole number, one is a radical expression. So I'm just going to add the 4 to both sides, but I'm going to add it right in front of the radical expression. So these 4's will truly cancel out on that side of the equation. Ooh. Let us see. I'm having a technical difficulty now. Oh, who should I thank? Probably, I'm trying to think of a mathematician. Carl Gauss. Okay, thank Carl Gauss. All right. In any case, we're trying to move this -4 over to the other side to be with this radical expression. So now we have the x by itself, since these 4's cancel out, and then we'll have just +4 plus or minus 2 root 3. And this expression does not simplify any further. So this is the solution, as crazy as it looks. There are 2 solutions there, 4 plus 2 root 3 and 4 minus 2 root 3. Okay. You don't necessarily have to write it out. Well, in MyLabs Plus, they'll ask you to write it out like either like this if they give you the plus or minus button, or you'll write 4 plus 2 root 3, comma 4 minus 2 root 3. I know you can't really see that, but this will be an acceptable notation for both solutions, just so that they're compact. And these are really 2 numbers, but they're going to be really strange numbers if you throw them in the calculator. So just to show you that they are 2 different numbers, 4 plus 2 root 3, 2 root 3 is 7.46-ish. 4 minus 2 root 3 is about 0.535-ish. Okay, so they are 2 different numbers. They're in 2 different locations on the number line. But these are decimal approximations. They're not good enough. We need the exact expression. So that's why we have to leave our answers in this form. Okay. And I think that, I believe Yvonne was able to get this problem, but you might have felt tempted to add the 4 to the back of the expression. And just trust me when I say that it's convention to put that whole number first. Okay, that's just the way mathematicians tend to do it. It wouldn't be necessarily wrong, but there's some ambiguity about the order of operations if you throw it in the back. Because is it plus 2 root 3 plus 4, where you distribute the +1? So if you put it in the back, it's just a little bit more confusing. So go ahead and throw that whole number in the front. Does anybody have any questions about this one? We'll definitely need some practice, right? Is that what we're thinking in our heads right now?
Yes.
Okay. Yeah, definitely. And practice is the name of the game. Let's look at number 3. 3 is going to be real similar. And that's going to be 2x minus 8. That whole quantity is squared, and that's equal to 24. Can anybody tell me what the first step of this problem is? And I know you might feel tempted, but the first step is not to log out of the Zoom session. Okay. So what do we want to do here?
Put a square root.
Yes, exactly. So I'm going to go ahead and copy this problem down just so that my notes don't look a little crazy. You take the problem, and then we're going to use the square root property. So I'm going to say here, let's say step 0 is to make sure the squared stuff is isolated. So I'm going to put the stuff that's squared is isolated. Then step 1 is going to be to use the square root property, which in layman's terms is going to be take the square root of both sides. Boom, boom. When we do that, we'll be able to break open. I like to think of it in my head like these guys are trapped in the prison of the squared operation. So when we take the square root of this side of the equation, we're breaking those terms, that expression, we're breaking them out of jail. So that's equal to plus or minus. Now remember here we need to simplify. So we could simplify 24 into I think 4 times 6 will do. And if you take the square root of 4 times 6, well, 4, we can take the square root of that and call it 2, but you can't take the square root of 6. So you should get, you should get this. 2 root 6. If you're not sure why it should be 2 root 6, take a moment to go ahead and factorize 24. And then try to go through that simplification process. I'll give you guys about 30 seconds to just examine it. Okay, I know that was less than 30 seconds, but it's sort of excruciating for me to like sit here. So we'll have 2 root 6 here, since that's the simplified form of 24. And just because I have just been filled with the fear that I'm wrong, root 24 is that, and let's see if 2 root 6 is the same. Yes, they're the same value. Okay. So now once you have simplified the radical, then what we might want to do is go ahead and give ourselves some space over here on the right-hand side. So I'm going to put this little gap in front of the expression plus or minus 2 root 6. Okay. All I'm going to do is add the 8 over to the other side and use the addition principle here so that the 8 goes right in front. 2x is equal to 8 plus or minus 2 root 6. And then finally, we need x by itself. So why not divide both sides of this expression by 2 so we can get x by itself. X is then equal to this guy. But this guy can be simplified. Remember, we need to break apart the fraction. So 8 over 2 plus or minus 2 root 6 over 2. And then we're going to simplify the fractions, but keeping in mind that if we have a radical expression, the number inside the radical is trapped in that operation. This 2 or this denominator can only interact with the numbers that are on the outside. So when we simplify this, the first fraction is 8 over 2, which you can interpret as 8 divided by 2. Okay, that is going to be 4 plus or minus. And then this expression, we sort of want to ignore the radical since that cannot take part in the reduction. And then 2 divided by 2 is just 1, right? So if 2 divided by 2 is 1, then 1 times whatever we have left over is just whatever we have left over. So then this must be the solution. Which, if you wanted to write it as the solution set, would be 4 plus root 6, comma, 4 minus root 6. Does anybody have any questions about those or about that one? Okay. Well, I definitely would like to spend more time on the square root property, but since we saw it a little bit last class and we saw it a little bit today, I'm going to have to say that if you need more practice with it, it's in the homework, it's in the review. You'll get it. Just make sure that if you need to talk it out with somebody, that you're going to Math World, because we need to move on to the next strategy for solving quadratic equations. Okay, so let's take a breather and then release so that we can shift gears to method 2. Solving quadratic equations using the zero factor property. Okay, so this is a new property, but it's really a simple idea. Okay, and let me just break down the zero factor property for you here. The zero factor property. Imagine you have two numbers. And let's just call them A and B. And they're multiplied together. And when they're multiplied together, they produce a product of 0. So in other words, A times B is equal to 0. What do we know about either the value of A or the value of B? Do we know what one of these numbers is, or maybe both of the numbers are?
One of them 0,
Yeah, and why does one of them have to be 0?
because anything times 0 is 0.
Yes. So either A or B or both are 0 since anything times 0 gives you 0. Does that make sense? Does anybody have any questions about that? Right? I mean, this is a concept that we've learned since grade school, right? That something times 0 gives you 0. And so at this point, that simple concept with numbers should be pretty clear, or at least automatic a little bit. Even if you don't necessarily understand why it is, you sort of believe that it's true. Okay. Well, it turns out that if I have two polynomials, now that's the trickier thing, right? We've gone from numbers a and b to two polynomials that multiply to 0 then one or both, or let's say one or the other polynomial must equal 0. Okay. I realize there's not a lot of numbers here, so I'll give you some time to write that down. Is anybody still writing?
Yes.
Okay.
Okay.
Okay. So in practice, the zero factor property to solve quadratic equations will generally look something like this. That you'll have some, let's say, ax squared plus bx plus c. Some quadratic trinomial is equal to 0. So let me label this a little bit. This is a quadratic trinomial in standard form. And standard form is always set equal to 0. That if you can take this quadratic trinomial and factor it, that you might be able to factor it into something that looks like x plus, let's say that this is x plus h. I'm just choosing a random letter there, and that letter will change, or that number will change depending on how this particular polynomial factors. And this one we can call x plus, I'll put k here. So if you can factor that quadratic trinomial into two factors that, remember, these are being multiplied by each other and they give you this polynomial back. If these two factors are equal to 0, well, that's two factors being multiplied to give you 0. So if the zero factor property says that something times something else equals 0 implies that either the first thing is 0 or the second thing is 0, then we can use that same logic here to say that either, let me write that here. Either of these is true. Either x plus h is equal to 0, or x plus k is equal to 0. So what we get is two linear equations that now we need to solve to isolate x. So if I wanted to get x by itself in this first equation, well, I would just subtract the h over to the other side. And I would say that my solution here is x is equal to negative h. That'll be one solution. And for this one, whatever this number is, I would just say minus k to both sides of that equation, because that's how we solve a linear equation. That would give me x is equal to negative k. So that's a different solution, potentially. So my solution set in this like really weird example where I don't have any numbers in it at all, except for 0. Your solution is going to be negative h comma negative k. And that's the basic gist of how we apply the zero factor property to this new thing that we're doing, which is solving quadratic equations. So you're going to have to put on your thinking cap and look at the quadratic equation that's given to you and ask yourself, what strategy is going to work here? Can I isolate the squared term and take the square root of both sides? Or do I have a quadratic trinomial and need to factor that first? Okay, so let's look at some concrete examples. So example. Solve using the zero factor property. We're given 2x squared minus 14x plus 24 is equal to 0. Okay. Well, let me sort of divide up this piece of paper because I might throw some scratch work over here. And I might need a lot of scratch work. So I'm going to write over here, this is my scratch work. Can anybody tell me how I might go about factoring this? What might be the first step? Right, when you see the zero factor property in the instructions, factoring is going to be the first step. Do each of these terms have something in common, some common factor?
A 2?
Yeah, so that might be the first thing. So I'm going to say step 1 is to factor the trinomial. And the first thing that we're going to want to do is look to see if there's a GCF that we can factor out. So what I might say is that this is 2 times x squared minus 7x plus 12 equals 0. Okay. So that's good. We've factored out our GCF, but can this trinomial here that's in the parentheses, can that be factored further? Well, if I have a trinomial, then I might want to try the AC method. So in this particular example, your A, B, and C, let's go ahead and label those. Remember, for the trinomial, we have A, B, and C. And we call it the AC method because we want to take A times C. So since there's not a number here, we understand that that's a 1. The coefficient is a 1. So 1 times 12 is just going to be 12. So A times C is equal to 12. You may or may not remember, but we look at all the factors of 12, which is 1 and 12, 2 and 6, 3 and 4. And then you want to select the factors that are going to add to give you a 7 or somehow combine to give you a 7. And that'll be 3 and 4. Well, 3 plus 4 is going to give you a positive 7, but here we need a negative 7. Remember, we need those conditions to match such that A times C gives you a positive 12. But then when you add those factors together, you get the term in the middle, or that coefficient in the middle, which is negative 7. So the correct selection here is going to be 3 and 4 for sure, but they both need to be negative. So that negative times negative gives us positive, and then a negative plus a negative gives us this negative. Okay. Does anybody sort of vaguely remember that? Okay. So that means that I can break this polynomial up, and I'm just going to sort of ignore the 2 for a second. I'm going to break this up and call this negative 3x minus 4x. So that middle term, these two middle terms, they do combine to give us the negative 7x. I can bring the x squared down and the plus 12. And I'm sort of also ignoring the 0 for a second just because I need some space to write. And now that I have a 4-term polynomial, I can factor by grouping. These guys have an x in common. So I'm going to factor out an x, and I get x minus 3 left over. These guys have a negative 4 in common. Remember that if this is negative, you're going to factor out a negative. And since they have a 4 in common, I can throw the 4 there and call this negative 4 times x gives me back the negative 4x. Negative 4 times negative 3 will give me the positive 12. And since these guys match, that tells me I'm on the right track. X minus 3 times x minus 4 is the factorization of this trinomial. You just have to remember to bring the 2 down. And that's equal to 0 now. So I factored my quadratic equation. I'm going to give you guys a little bit of time to write, like to catch up with the writing, but also to emotionally catch up a little bit. Does anybody have any questions? Comments?
So really, yeah, so after 1A, B, and after you do the AC method, then would the next part of the scratch work be to factor it out using that other method?
Yeah, so once you have factored it using the AC method, we have a factor times a factor times a factor, right? This is just a product. Something times something else gives us 0. So at that point, you're going to use the 0 factor property. Which says that if I have 3 numbers here, or 3 expressions, 1, 2, 3, and they're all being multiplied, what I could do is say that, okay, 2 is 2 equal to 0? Well, 2 is obviously not equal to 0, right? 2 will never be equal to 0. So I know that 2 is not equal to 0. But in order for us to multiply this, this, and this together to get a 0, that means that this guy or this guy must be equal to 0. Or both of them could be equal to 0. Does that make sense? Or are there any questions about that?
Where did you get the x minus 4? Where did you pull that from?
Oh, when I factored,
Okay, you combined the x and the, okay, got
yeah,
it.
so this is the greatest common factor of this expression. So I factored that out to the front.
Right, okay.
And then this becomes your other factor. If you were to multiply these two out together, x times x would give you the x squared, x times -4, -4x, -3 times x gives you that, -3 times -4 gives you the 12. So we're factoring it so we can write it as the product, because the zero factor property says that if you're multiplying these two things together and you get 0, then one or the other thing needs to be 0. That's the only way you're going to get a product of 0. 2 will never be 0, so you don't have to worry about the value of 2 here. One of these has to be 0. Well, that tells us then that either x minus 3 equals 0 or x minus 4 is equal to 0. So using the logic of the zero factor property, we have these two linear equations now, and we can solve the two linear equations to find x. So this equation, when you move the 3 over, you get x is equal to 3. And when you move the 4 over here, you get x is equal to +4. So your solution set is 3, 4. Those are the two possible solutions. X is equal to 3 or x is equal to 4. Okay, so I want to use this as a roadmap and give you guys your own practice problem. Yeah. And these are a little extensive. They're a little bit long. So let me give you this problem. Yeah. Solve using the zero factor property. And it's going to be 3x squared minus 2x is equal to +5. And I always do my scratch work somewhere else. So I highly recommend that you do your scratch work somewhere else. One other note is that I noticed that on test 1, some students were trying to really squeeze in their work into the piece of paper. You want to give yourself a lot of space to do the scratch work because you're not going to be able to squeeze it into the bottom corner of your paper. I won't be able to read that, and you won't be able to understand what's going on. So make sure you give yourself a lot of room. The first step is to make sure the quadratic equation is in standard form. So we need it in the form ax squared plus bx plus c is equal to 0. And then the next step will be to factor the trinomial. I'm just going to write down the roadmap for you, and then I'll throw you guys into breakout rooms so you can talk out this problem together. After you factored the trinomial completely, then you're going to use the zero factor property to separate out two. I don't know, I started counting down. You're going to separate that out into two linear equations, and then you're going to solve the two linear equations, which means x equals something and x equals something else. So you'll have two solutions there. Okay, so once you've written down this problem, let me go ahead and let's go ahead and get started. So the first step is going to be always when you're working with some trinomial that we need to get it in the form ax squared plus bx plus c equals 0. And, you know, don't take these plus signs too literally. Depending on the problem, depending on the day, these might be positive, they might be negative, but that's not the important thing. The important thing is the form of the quadratic. We need to have a trinomial on the left-hand side of the equal sign so that we can factorize that trinomial. And we usually factorize trinomials using the AC method. So if we look at these two, and maybe I'll need a little bit more room here. Let me go ahead and write this on a new sheet of paper. Because I realize that whenever you're going to factor something using the AC method, you need a lot of scratch space. So we have our equation in standard form. You might label this as a is equal to 3, b is equal to -2, and c is equal to -5. And then we call it the AC method because it's cool, 1, and 2, because you're going to multiply a times c first. So that first one, if you caught it, is a joke. AC, it's cool. Anyway, 3 times -5 is equal to -15. And then you're going to factorize this. So just examine the factors of 15. We're just going to be very loosey-goosey with this negative sign just for a second. 1 times 15 is 15, and 3 times 5 is 15. Okay. Well, I know that I need to combine those factors somehow to add them to make this middle term b, which is -2. And I need to be able to multiply them to make this -15 that I got. So what factors do I have to use then? Well, it seems like I have to use the 3 and the 5, because that's the only thing that's going to give me a 2. But 3 plus 5 does not give me -2. But if you remember that one of them has to be negative when we multiply them to get a negative, then I get to be a little bit playful with where I place that negative. If you put -3 plus 5, you would get a +2, and that would be incorrect. So that's what tells us that it needs to be the -5. So 3 times -5 does give you the -15. Does anybody have any questions about that? Okay. Well, then we can say this middle term needs to be broken up into these two terms. One of them is going to be 3x. The other one's going to be -5x. Okay, and this is a positive 3x, so might as well put a plus sign in front of it because we need to bring down the terms on the end, which are 3x squared and -5. Are you guys okay with that? This expression is a 4-term polynomial, and if you were to combine these like terms, you would definitely get this -2x. We can make this substitution now because this is equivalent. It is equal in value to this original trinomial. But the thing that we like about this 4-term polynomial is that when we factor it, we can write it as a product of two polynomials, and those polynomials will be multiplied together and will be equal to 0 so that we can use the zero factor property. So if we look over here, these guys have a 3x in common. So 3x comes out. That will leave you with an x here and a, what would that be? Plus 1. Okay, and you can always back check that because 3x times x gives you 3x squared. 3x times 1 gives you 3x. Similarly over here, they have these two terms have a factor of -5 in common, so we'll go ahead and factor out that -5. That's the greatest common factor of these two terms. And when you think about rolling forward that distributive property, -5 times x gives you the -5x, and -5 times here, you got to be careful. It's got to be a positive 1 so that a negative times a positive gives you back that negative. But in any case, this polynomial here and this polynomial here are like they're common factors of this term and this term. So we can factor out x plus 1 since it's the greatest common factor. And the 3x minus 5 is your other remaining factor. And sure enough, if you wanted to, you can multiply these out and you would get this original trinomial. So we have factored our polynomial now, and you just have to remember that this is equal to 0. At this point, you need to remember the zero factor property. Because I will tell you this, a lot of students, they stop right here and say that this is the answer, and they get it wrong. I can only give them half credit if they factored correctly. Because when you're solving an equation, you have to get x is equal to some number, some expression. Okay, so don't just stop here. Use the zero factor property so that we can find x. And the zero factor property says that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. So this guy is going to sort of play the role of a. This guy is going to sort of play the role of b. And we can just say x plus 1 is equal to 0 or 3x minus 5 is equal to 0. That's two linear equations that we need to solve. The first one's pretty easy to solve. We can just move the 1 over to the other side. So x equals -1. There's one solution. This one requires a couple steps, right? First, we need to move the 5 over. So we'll add 5 to both sides. So we get 3x is equal to +5. And then to isolate the x, we need to divide by 3. So these cancel out and you get x is equal to 5/3. And since that fraction can't be reduced any further, we'll just leave it alone. And your solution set, should you choose to write it out this way, or if it's required by MyLabs Plus, is going to be -1 and 5, 3. Notice that when I write the solution set with the braces, you don't have to put x equals. You're just going to put the numbers as that solution set. Does anybody have any questions about that problem?
In MATLAB, can you use just parentheses and not like those brackets? Will that work?
They will put the braces here for you.
Okay, okay,
So you're just going to type in the number, comma, the other number.
okay.
Yeah. Any other questions?
After seeing you work that out, I realized that I really wasn't lost and I was over processing things.
Yeah. Great use of that term. If you definitely over process, you're going to feel a lot of anxiety and you're not going to know what you're doing or where you are. But you sort of have to like take a step back if you are over processing. Like this is weird. It's a little bit of a psychology game because you're going to psych yourself out with some of these problems that have a lot of steps. In fact, when I'm working really long problems with calculus students, sometimes I get lost too, and I don't know where I'm going. So I have to sort of take a step back, figure out, remember the forest as opposed to just focusing on the trees, and try to tell myself, okay, what is the main goal here? Because there's a lot of little goals in the path of getting to your main goal, right? Just like life, a lot of little goals that build up to something bigger. So usually those little goals will help guide you. There's a lot of benchmarks where you can see, okay, if you're doing this correctly and these guys match, then you're on the right track. If you got these factors and you multiply them out, and if they match with the original problem, then you're on the right track, right? But you have to get into this sort of self-regulation mode. It is a big psychology game. And only with practice will it feel natural, because I definitely understand that it does not feel natural at first. With that being said, we're going to take a 10-minute break. So let's come back at 2:10, deuce dime. That's San Antonio, countdown city. 2:10 is when we'll return. And then we'll look at the final method for solving quadratic equations. Okay. Then the party goes on. Party on Wayne, party on Garth. Welcome back to the podcast. So we're going to start in on the last but not least of the methods of solving quadratics. So method 3. We're going to solve using the quadratic formula. So we're going to solve a quadratic equation using the quadratic formula. And so what we need to do before we jump into this is, one, I'm going to write the formula down for you. You can think of this as just a plug and chug method of getting your solutions for that quadratic equation, provided that the equation is in standard form. So if we have ax squared plus bx plus c equals 0. So make sure that this condition is met before you even start plugging things into the formula. We need standard form. So given a quadratic equation in standard form, you can solve any quadratic equation. And maybe I should be more explicit here. You can solve any and every quadratic equation that you will ever come across with the following formula. And some people might remember the formula vaguely from high school. For some of us, high school was a long time ago, and we prefer not to remember those times. But in any case, let me write the formula down, and then I'll sort of explain a helpful mnemonic for remembering it. And that is, your solutions will be x is equal to, now this is a big one, so I'm going to take a large breath, negative b plus or minus the square root of b squared minus 4ac. That's all under the root. And then that is all over 2a. Now this means that whatever numbers you're given here for a, b, and c, if you plug them into this formula, they will spit out both of your solutions. Plus or minus indicates that there's going to be two solutions here. To test out this fact, we worked this particular problem already, and we solved it using the zero factor property, and we found that the solution set was -1 and 5/3 if memory serves. Okay. So why not solve this again, but using the quadratic formula? Okay. So because this is a big, hefty formula, there's a couple of ways to remember this. You won't have to memorize this because I provided it for you on your test 2 reference sheet. But another healthy way to remember it is that you can tell yourself the story of the negative boy. And here's the story of the negative boy. Okay, I'll write it down later, but I just want you to listen to this. Okay. The negative boy was uncertain of whether to go to the radical party because the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. in the morning. Okay. The negative boy was uncertain of whether to go to the radical party because the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. in the morning.
I think I have to watch the formula first to remember the story.
Yeah, but then once you have the story down, the story guides you to the formula because the negative boy is -b, uncertain is plus or minus, radical party, radical sign, boy was squared, missed out, so it's minus, subtract, 4 awesome chicks, all over at 2 a.m. I didn't learn that until I started working at Math World and at St. Philip's. A very nice lady named Donna, very, very knowledgeable. She's taught mathematics, high school math, and been tutoring at St. Philip's for a long time. I think she has over 40 years of math experience, and every time I interact with her, I learn something new or some new way to appreciate the stuff that we teach. So if you ever work with somebody in Math World, Donna's really good. But in any case, I think it's a really funny story. And there have been times in my life, when I was in school and I just totally slipped up on, what was the quadratic formula again? If I had known the story of the negative boy, it would have really helped. But let's go ahead and jump into this problem. So we're going to look at, we're going to solve this problem using the quadratic formula. So this equation that we were given before was 3x squared minus 2x is equal to +5, but I'm going to go ahead and say that this is -5 equals 0. So we don't have to worry about putting it in standard form. You will have to check that it's in standard form before you do anything, but in this case, I want to just, start the show and get the show on the road, sort of. Every time I need to use the quadratic formula, I write it down. So the first thing I do is write x is equal to negative boy was uncertain of whether to go to the radical party because the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. Boom. Okay. And the nice thing about having your equation in standard form already is that we can go ahead and label your coefficients. So a is equal to 3, b is equal to -2, c is equal to -5, right? We've been labeling it that way since we started factoring trinomials. So it's nice and convenient that these labels correspond to these variable terms inside our formula. So what we need to do is say that we can generate our solutions by using this formula, but what my tip is going to be here, so that you don't make any mistakes as you're processing this. Wherever you have a variable like B, A, or C, insert them into the formula using parentheses. So, for example, this says negative B. I need the negative sign from the formula, so I'm going to write the negative sign from the formula. But then I need to insert B, so I'm going to put parentheses as a space holder, and I'll plug in the value later, okay? Plus or minus comes from the formula. The square root of something or another comes from the formula, but then I need a variable here, or variable value, b, so I'll put parentheses, squared minus 4. AC is going to be a times c, so I'm going to put 2 parentheses there. All of it is going to be divided by 2 times something, so I'm going to put parentheses there. So pre-process the numbers or the expression by putting the blank parentheses. It is going to save your life in terms of negative signs, losing negative signs, because that is like one of the #1 killers here. Okay. Then we just need to make sure that we're plugging things into the right location. So I know I need a B here and a B here. B is -2. So I'm going to put -2 here and -2 here. Notice that because this is a negative, this negative comes from the formula. This negative comes from the value that I'm plugging in. A lot of times students will say, oh, it's negative B, and since that's -2, I'm just going to put -2, and they'll leave off a minus sign. Again, the parentheses are going to help prevent or cut down that error. Okay, you plug in your B's, then we have AC here, so I need the 3. Going to plug in the 3, going to plug in the -5. 2A, that's going to be a 3 down here. Okay. So let's say that step 1, I don't know why I put 1, step 1. Make sure that it's in standard form. So standard form and label the coefficients. Step 2 is to properly plug in your values for A, B, and C. Three is going to be a multi-step process. Really, we're just simplifying the expression now. Simplify the expression or the formula. But let me do like a little Roman numeral I here. The first thing that I usually simplify is if you have a negative here, just call that positive. So simplify the negative b first. So what I would say is that this is x equals negative is going to be 2. Okay. The next thing that you will simplify is everything inside of the radical. And inside the radical, you have this expression, and you'll want to carefully simplify this using your order of operations. I will tell you a hint here. You can use your calculator to simplify the stuff inside the radical as long as you type it in exactly the way you wrote it. So when I say that, I mean you need the parentheses. If I put -2 close parentheses, let me zoom in so you can see. In the radical, we have -2 squared -4 parentheses 3 parentheses -5. That's the stuff inside the radical. It has a special name called the discriminant, but we don't really need to know its special name. Just know that as long as you type it in exactly the way you wrote it here, when you hit enter, it will give you the correct value. Now, the reason why you want to do this is because if you were to get a negative number here, then the calculator would not be able to take the square root of it. So let's just go ahead and, to be safe, simplify the inside first. Because for instance, if we had done the square root of, I don't know, let's say it was like a 12 squared for some other problem, minus 4 times 3 times negative 5. Oh, that one worked out. Let me see if 4 times 5 is 20. Let's say that this is positive 5. Let me say positive 10. Nope. Anyway, if you were to get a negative number here, obviously, if I got negative 64, for instance, the calculator wouldn't be able to handle it. Negative 64 gives you an error because that's an imaginary number and the calculator just doesn't deal with imaginary numbers. So simplify the stuff in the radical, and then the third step is to simplify the denominator. I'll just put denom. Okay, so 2 times 3 is going to be 6. Four will be to finally simplify the radical. So we could call this 2 plus or minus. The square root of 64 is nice because it's a perfect square, so that's going to give you 8 over 6. And then the last step will be to simplify the fraction. And I'm going to say simplify the fractions because at this point we should break this up and then simplify the fractions. So 2 over 6 plus or minus 8 over 6. And that reduces to 1/3 plus or minus 4/3. Now this doesn't look like it matches the solution that we got from the last problem, which are -1 and 5/3. But remember, this is two solutions. The first is 1/3 plus 4/3, which sure enough is 5/3. And the other option would have been 1/3 minus 4/3, which is going to be -3/3, which reduces to -1. So you do indeed get the same solutions. Okay. Well, I do want to give you one so that you're able to practice here in class. So let's do that. The quadratic formula is super useful because not all of the quadratic equations you're going to run into will be solvable using the other two methods. So if you're not able to figure it out using the square root property, or the polynomial might not be factorable, then you can always fall back on the quadratic formula. It will always give you the solutions. So let's see. Give me just one moment. Let's do that one. Solve using the quadratic formula. Let's go with 5x squared plus 12x plus 6 is equal to 0. And let me go ahead and write down the formula for you guys. X is equal to the negative boy plus or minus. The boy was a square, missed out on 4 awesome chicks, all over 2a. Okay. So I'm not going to put you guys in breakout rooms, but I will give you guys about, let's say 5 to 10 minutes to try to plug these numbers into the formula and then simplify your expression. And obviously I will be here, but what I really want you to do as you start to run into problems, if you run into problems, ask each other, talk it out.